Hello guys, today we're going to talk about uh, analogWrite in the Arduino framework. So last time we talked about digital write and digital input affecting our digital output. Today we're going to talk about an analog where we want to manipulate the brightness of the light in analog write. So what analog write basically does is the pulse width modulator to manipulate the voltage that is coming out. So what it does is basically pulse width modulation is sending out a signal, digital signal. It's not actually analog, but it acts as though it was analog. So the pulse width is basically a wave of a digital signal that's going up and down, but it varying rates. It varying. How can I say? It changes how much time it is on, how much time it is off. So the more time it is on, the more it seems as though the higher voltage. The shorter time it is off, the less though it is a high voltage. So this can be used to manipulate the brightness of the light. So the light is basically turning on and off. It varying makes it seem as though it is in bright. The human eye, so it simulates as though it is changing in bright. Okay, so how do we do? So initially we want to just same function we're using before. In mode, I've already cleared a variable named LED. I've put it on 2 because that's where I want to put my. Usually you would put a resistor with an LED, but in simulation it won't affect us much. Okay, so I'm saying in mode LED, then we're getting it out as an output. It's just always just as we're doing in the digital output. So we've selected our pin mode. Now we want the light to actually turn on. So we're going to create a for loop which is going to increase the brightness. We're going to create an integer code brightness and equate to 0. Then we want to create a limit brightness to 55. Now this is the highest value the value get. This is the highest number the value can be 255. Goes up to, remember in computers we always start counting from 0, so it has 250 values from 0 to 255. Those greater than 255, then more bits are available because 256 is the power of. So if state brightness is 5, then we're going to iterate our brightness and we go through the for loop. So we're going to put in, now we actually want the light picture. We're going to say analogWrite. Going to write our pin, which is LED. Then we're going to write bright. So what's going on here? So each time it goes through the for loop, each time it goes through the for loop, we're going to assign a value to the variable brightness. Then it's going to put that same value into this analogWrite function, and this value is going to affect the LED pin. So we want to put a delay here. In my simulation is a bit slow, so I want it to play for a pretty short time. Then so every 10 milliseconds is going to go through the loop. We're going to assign a value to analogWrite, and that value is going to increase time it goes through the. So next we're going to create a for loop that's going to do the opposite. I'm just going to copy this for loop. It's going to be similar to this. So for int brightness, it's going to be the opposite now. We're going to start from 5. We're going to say is greater than or equal to. We're going to end at 0. Then the brightness has to be. So we're going to do exactly the same thing, only reverse. So it's going to increase the value up to 255, then increase the value up to 0, then increase the value up to 5 going to go on forever, because remember we're in the loop function. So once we're done with that, we're going to port our binary cloud binary. Then we can that I've already selected the file in the Proteus. I showed you how to do that before. Already exported the file. Once we run this, as I said before, my simulation is a bit slow. Okay, as you can see, turned on and turn off. So it turned off. Okay. So it's doing this a bit fast. I'll try to do this on actual hardware, but actually increasing in brightness until it's at that level, then decreasing in brightness until it's zero each time that it iterates. Okay, thank you for watching. This has been the video on analogWrite.